Hello.
Hey, it's us again.
Welcome to You Choose. It's us. Welcome.
Yeah.
This is You Choose. It's a choose your own adventure style show where we're navigating our way through the entire CNCF landscape. And today, what are we talking about today, Victor?
Today we will be talking about runtime policies or
Runtime
security,
policies.
right? What is happening inside your, in this case, Kubernetes cluster, right? Not how do you prevent things from getting in, but what happens when they're in.
What happens when they're already there, when they snuck in, when our admission controller policies from last week didn't catch it, right?
Not only didn't catch it, right? Admission controllers are not going to catch many of the things because many of the things are not really in the domain of admission controllers, are not catchable from the API level, right? Now, whether somebody is executing a process from inside your container that shouldn't be running, that's not something you're going to catch with admission controllers, right? Because admission controllers are mostly preoccupied whether the manifest you are trying to apply to Kubernetes is correct, whether it's what it's supposed to be, rather than what's running there is what should be running.
So we're kind of jumping ahead in terms of the show formats, but we are going to.
Of course we are, because we're not prepared.
One of us is very prepared, always.
But you're okay as well, Whitney.
Yeah. Totally. Greetings to everyone who's coming in. Thanks so much for saying hello and where you're from. I love that this is a global community. So freaking cool. Let's talk about last week. Let's talk more about admission controller policy that we covered last week. We had 5 technologies to choose from. Can we give a quick one-sentence synopsis that's like what is each, how do these different choices, how are they different from each other? So we have validating admission policy.
Okay, I'm going to answer each of them with 1 or 2 sentences max, and then we'll see. Baked-in policy, admission controller policies without mutations, baked into Kubernetes soon.
Soon, I like that. It's a beta now, validating admission policy. Awesome. And then Caverno.
Same thing, but not baked into Kubernetes and available right now, plus additional features like mutations and verifying signatures and quite a few other things.
Resource cleanup and such, yes. Awesome. So like more complex and not baked into Kubernetes. And then we have OPA Gatekeeper.
Made before Kubernetes, in the meantime made to run natively in Kubernetes, OPA, and in the meantime changed so that it's not only OPA, but almost anything else you can think of as a way to define your policies.
Excellent. So not just Kubernetes specific. Well, Gatekeeper is Kubernetes specific, but
Gatekeeper is Kubernetes specific, but OPA has nothing to do with, I mean, it does have something to do with Kubernetes now, but OPA was born before Kubernetes was a thing. It's meant to allow you to define policies for something, whatever that something is, right?
For all kinds of cloud resources, databases.
It's a language.
Running outside of Kubernetes. Rego's the language. It uses a specific language. And then we have KubeWarden.
Everything we said before, but this time running as WASM. Focused on Kubernetes, but it can run outside of Kubernetes, and it can be written in any language you want as long as that language can compile to WASM.
Awesome. So write policy in any language you want, run it as a WASM module within the KubeArmor policy engine.
And with that comes all the good things about that come with WASM itself. Like it is your favorite word, sandboxed, right? It's isolated and all the stuff that come with WASM, right?
Yep. Cool. And then last but not least, we had Cloud Custodian.
Cloud Custodian originally serves slightly different purpose than typically admission controllers, at least the way I see it. It was more serving, hey, we are an organization, we need a tool that will help us figure out what we are running right now because we don't know how people did what they did, which tools they use, if any, and so on and so forth, right? So it was designed to exercise some kind of control, some kind of policies against your resources wherever they're running. In the meantime, we got also admission controllers for Cloud Custodian. What I'm going to say is that Cloud Custodian is very different, very special in a positive way, right? Compared to others. It has different approach that somehow converged into Kubernetes admission controllers.
I think it's Kubernetes integration is less mature than the rest of the tech, is my understanding.
Yeah, that's not the main goal of it, right? But it works.
Yeah. But to me, in my head, Cloud Custodian and OPA seem kind of similar, that they both can run all of your resources regardless of whether they're in Kubernetes.
Slightly, right? OPA is acting as in a similar fashion as admission controllers, it's just that it doesn't have to be admission controllers. But the primary purpose is to prevent things from happening if they shouldn't happen, right? But Cloud Custodian can do that, but at least the way I see it, it's more geared towards, let us see what is actually happening right now.
Okay. All
What
right.
are all the buckets that do not fulfill certain requirements and so on and so forth?
As the name custodian implies, it's there to clean up a mess that's already been made, as opposed to maybe open policy agents helping you not make a mess in the first place.
Exactly. I mean, both are entering into each other's territory, but that would be the, you know, when you look at it from the primary objective.
Right on. So now, drum roll. So wait. Before we reveal, I have a question for y'all who are in chat, and if you're watching recorded, please do post in the comments. What did you think about voting in Slack as opposed to voting in Twitter? We had less people vote, but I imagine there were meaningful votes because people took the effort to come and vote. So anyway, I'm pretty into not supporting Elon Musk when possible, but what do y'all think? Is Slack too much of a barrier for you to vote and you'd rather have it in Twitter? We want to do what the people want. So give us some feedback, please.
Oh, we're people pleasers now, huh?
Everything's up for a vote. I'd put this part up for a vote, except I don't know whether to put the vote in Slack or in Twitter. I'd let people vote on where to vote. Anyway, let's reveal the winner. Not the winner, the technology that was chosen. Yes.
Okay.
What did
Here we
y'all
go.
choose? There it is. You chose
Caverno it is.
There was some chatter in the You Choose channel on the CNCF Slack that they were hoping OPA would get chosen so that you would have to write Rego.
I already wrote it, so it's there are much more complicated choices for me personally than that one. We'll get to that in upcoming episodes, right? There is a whole episode with the tools that I never use seriously. So that's going to be a challenge. This one, not such a big one. Sorry, whomever said that, to disappoint you. Anyways, shall I walk through the demo and take a look at how all that works?
Yeah, let's add it.
There we go. Wait, that's the wrong screen I'm sharing. There we go. Okay. Cool. You wanted to say something. Say it now.
I was going to say maybe we can link to the CNCF demo repo that we have going. So if people want to implement another tech, they have an easy way to do it.
Yes. How about you add it to there and I will start the demo.
Okay. You start the demo. Yep. I'll hunt that link down. Cool.
Yeah. And just show it down, bottom left or whatever. Lower third. Okay. So here I have a policy that I already applied to the cluster, right? I'm just showing you now what I applied. It's a simple one. A couple of policies, all Caverno. Actually, more than 3-4 policies. Anyways, I have here one pro policy that you can judge by the name what it does. Essentially, I'm saying, hey, whenever there is a deployment and that deployment is applied to production and the operation is to create or update that deployment, the number of replicas must be greater than 2. So you must have 3 or more replicas for deployments defined in production, right? It's all YAML, it's relatively easy. And then the second one called DB cluster, which essentially says, whenever you apply something called SQL claim, whatever that is, in this case, it's crossplane, but doesn't matter what it is. Whenever you apply this resource and the operation is create or update, take a look at the parameter, take a look at the spec parameter size And the allowed sizes, and this is now regular expression, can be small, medium, or large. So whenever you create something called SQL claim, the only acceptable sizes are small, medium, large. And then another one that is almost the same. Again, SQL claim, but this time, if it's in production. So the previous one applied wherever it is, but this one, if it's in production, then the sizes can be anything you want but small, right? So 3 policies I have in my cluster right now. What I also did in advance is that I deployed my application to the production namespace. And that application, among other things, has, where it is, has deployment, right? So if you take a look at deployments, you can see that there are none. So I deployed application that has a bunch of resources, including others deployment. Deployment was not created. And the reason why it's not created, we can see if we describe cluster policy, that the first one I showed. And ignore. Oh my. I just discovered something I don't like about Caverno. I was not aware of. But I'm going to fix it now. So what you see here is the events. But if events are very old, they expired. So in other words, you don't see the message you're supposed to see because that thing happened 2 hours ago approximately, right? But what I'm going to do is to try to refresh it in Argo CD, which is what I'm using. And let's see whether it will detect it again. Okay, we're going to ignore that. You need to trust me that before it expired, there was a message here saying, hey, you cannot do that in the events because your deployment has less than 3 replicas, right? You need to have more than 2. So let's fix that, right? And we're going to fix that by changing. I'm going to open Vim, and I'm going to change the file YTT values prod. Now, today I'm using YTT, Carvel YTT, and the main reason why I'm doing that is because that's what you chose a long time ago. And we are now going to modify the what am I modifying, Whitney? I forgot. Number of replicas. Yes. Okay, here we go. I'm going to put replicas is 3, and I'm going to generate the YAML here with YTT. And if you take a look at the deployment somewhere there, where are you? The replicas 3, right? So I changed now to 3 replicas. I'm going to add that and commit and push to Git. Argo CD is going to deploy it, hopefully, if everything works. Not always. Everything works. And then
again,
if I
Argo CD is what you chose. You the people.
Yes.
Yeah.
It could have been Flux. It could have been some other choices, but you chose Argo CD. And now if I take a look at the deployment, something is not working. Still, let me double check. I'm going to bring Argo CD to the screen, see what I messed up. Sometimes I mess up things. I'm good at that. And here is my application. I'm going to go inside, and deployment is not there. What did I miss? What did I miss? Whitney, help me.
There was a warning in the UI.
Yeah, I know. That's to be
Okay.
ignored. Let's take another look, whether it's now working. Not working. Oh, I know what I did. No, I know what I did. Ha! Silly me. Edited the wrong file. This is the file, I think. No. No, that's the right file.
No,
That's
that has
fine.
3 replicas. Yeah.
I don't know what I messed up. Okay. Here's what we're going to do. We're going to postpone the demo. I'm going to figure out what I messed up while we go through the next stage. Does that sound okay? Cool.
That sounds okay. So as part of a policy, you would put in your error message that people will see when they mess something up so that they could have like a teachable moment you could take advantage of. But we didn't
Exactly.
see that because you were preparing and had already.
Exactly.
So I didn't. Yeah.
I think it expired because I tested it before I joined here 2 hours ago. It worked. I saw the message. Now I don't. I'm disappointed at myself, but I'll fix it. I'll figure it out while other people are explaining whatever we're going to hear today.
Excellent. So what we're going to hear today is runtime policy, and now's the part in the show where we talk about what is runtime policy. Your attention's gone until this is fixed, isn't it?
Whose attention? Whose attention?
So it's time to talk about runtime policy and what it is and why we need it. So we were just basically saying these admission controllers don't, Victor. Sit on your hands. Do what you need to do. There you go. The admission controllers don't catch everything. These are meant to catch things at the API level, at the Kubernetes API level, right? So like what particular objects are getting created in the cluster and that sort of thing. And they're not catching things at the runtime level. So what's likely to even happen at the runtime level that needs to be caught?
There can be many things. Let's say one scenario could be, for example, let's say that somebody or something somehow managed to get access to the container with your application, right? And starts running a process that should not run. And
so maybe there's there's a CVE that hasn't been caught yet, so it hasn't been scanned for. So that's what's running.
For example, or it could be a person who somehow managed to hack into the system and enter that container, right?
Okay.
It can be many things out of ordinary could be happening.
Okay.
And sometimes even some things could be happening because you wrote your code to do something that it shouldn't be doing, right? You're not going to catch that by taking a look at the YAML of the deployment that ultimately runs that code, but by taking a look at what's happening while it's running, right? So think of it like admission controllers being the entry point. This comes to the API, admission controllers say you can or you cannot, right? But now runtime is, okay, this is running. Is it misbehaving?
Okay.
If I take analogy with the humans, right? Kind of like, can it be born or not? But if it's born, can it do whatever that child is doing or not, right?
Oh, okay. That's nice. Yes. So something's actually running. A container image is pulled. It's actually running. Now we're watching the processes that are running and making sure they're doing what they're allowed to do. So we're watching that at the kernel level. So each host machine in the cluster is watching it. These technologies are watching at the kernel level of each host machine, right? And
it could be at different levels. It could be networking. It could be kernel. But they're watching what's happening.
At the networking level, okay, is that not caught by the MTLS and like networking policies?
Yes, that could be caught.
Yeah?
Some of those things could be caught by networking policies, some not necessarily, right? MTLS is not really catching that. I mean, MTLS could be also put somehow in that category. So it's a very broad thing, right?
Okay.
Many things can happen.
It's like MTLS says like this container is allowed to talk to this container. But then runtime security is saying like, wait a minute, you're not allowed to ask for that specific thing from that container, like maybe more granular.
Yeah.
Okay.
Or you're not even supposed to talk to that something in the first place.
Okay. Just because MTLS says you can, the runtime policy says you cannot.
MTLS does not necessarily tell you whether you can or no, but whether you are who you are supposed to be.
Ah, okay. That adds up for me. Cool. And so what I understand about runtime security and runtime policy too is that when it's watching the kernel, it's not necessarily looking for application specific things. Like we're not necessarily within the abstraction of an application at this point.
More on
process level.
Exactly, more a process level. Again, not necessarily only a process level, but yes, mostly on the level of processes. Can you execute? So let's say let's say that you don't care who or what, but hey, nobody should be able to list files inside of that container, because there is no good reason why you would do that. So if something or someone is listing files, that might be a smell of behavior you don't want.
Okay. And then other activities like that might be like opening a file. That's like, why would anyone need to open that file unless they're specifically authorized to do something, or like making certain system calls, or accessing a service token, or those sorts of things.
I think it's very often it's easier to decide what you can do than what you cannot. Because what you cannot do can be anything, right? Anybody having children understands perfectly well, but you cannot make a list of what you cannot do, right? But you can make a list of what's allowed.
So if you want to implement runtime security, then you would, with your application, you would need to monitor it for a while and like profile your application and figure out everything it's doing, and then say those things are allowed, and then say anything that's not that is not allowed. Is that how it goes?
I mean, it depends on the complexity of application, but very often it's not really that complicated to say what's allowed, because you can say, hey, I know that this is the binary that is allowed to be executed. That's the only thing that I really care about. That's my application. Any other process is unacceptable. And it is allowed to make those requests to or to do this or that. Kind of, I know what my application does. Now, applications tend to get complex, so it's not that as easy as I mentioned, but it's doable.
Awesome. Is it time to bring our guests on? Do we need to say anything else about runtime security? Okay. I'm saying runtime security and runtime policy interchangeably. Do you know if that's accurate? Am I missing?
I don't know. Ask the guests. Why are you asking me?
Okay, first up we have Thomas. Thomas is coming on today to talk to us about Falco. Nice to meet you. Will you tell us about yourself, Thomas?
Nice to meet you too, and thanks for the invitation. Really happy to be here.
So glad to have you. Tell us a little bit about who you are and what you do, and why we should trust you to teach us about Falco.
My name is Thomas Labarus. It's noted on your screen, and right now I'm senior developer advocate at SysDig. Basically, I'm talking a lot about Falco. I was before an SRE and a Falco user for a long time, I think 6 or 7 years. And I am also creator of some tools in the Falco ecosystem.
Cool. So Victor's already working on his, he's gone.
No, I'm listening.
Do you think it's
No, sorry. I'm pretending to listen.
Yeah.
Do you think it's accurate, Thomas, to use runtime policy and runtime security kind of interchangeably like I've been doing? Or is there some aspect of runtime security that's not covered by this concept?
I think runtime policy is just an area of runtime security. Runtime security is a global topic, how to protect your applications when they are in running phases in production. And you can have runtime policies, like Victor explained just before it came. They will explain what you are supposed to allow or deny from your applications. But for example, runtime security, you can also scan the images of the running pod. Not only the pods you are supposed to deploy, but you can from time to time scan the images of your pods to be sure a new CV has not been found for these applications running.
Fascinating. Okay, thank you for clearing that up. We're going to see you again very shortly, and you'll get your 5 minutes to teach us about Falco soon. But first, we're going to meet our other guests. Bye, Thomas. Oops. There we go.
You will notice that now I'm actually paying attention because I fixed the problem, but we'll get to that later.
Let's say hi to Barun. If you want to fix it before we jump into their presentations, it's fine. But first, we have Barun here. Hello. Tell us about yourself, please, friend.
Hey, I'm Barun Acharya. I work as a software engineer at Equinox. I am a maintainer and leading the development of the CubeArmor project that we will talk about soon.
Amazing.
I am also fellow CNCF ambassador, so
yes. So is Thomas too. I don't want to sell him short. The four of us, all four of us today are CNCF ambassadors. It's so awesome. So
we're
see
not
you.
we're not really inclusive here, right? If you're not ambassador, you cannot come.
We need some sort of tattoo that proves that you're really committed to CNCF before you're allowed to be here. No. That's not how it goes. We love everyone. But we just have to. The reason we do CNCF projects is because we have to scope this thing somehow. And that's as good of a way as any. But thank you, Baroon, and we'll see you very shortly. You have a choice to make, Victor. Do you want to show your working demo before we start these presentations?
Let's do it quickly. Let's go through it. Okay. Can you put my screen on?
Yes.
Okay, there we go. Here's my screen. Here's the application. What actually happened is that Argo CD did not try again to deploy the deployment after, but I reset it, and now you can see that the deployment is there. It is not yet ready. Pods are not running, but for other problems that are also in those policies, right? Mm-hmm. And we can take a look at pods, right? You will see that they are all getting confused because I can reveal without going into details. It's not running because it requires a secret. Secret is created when we create a database, and database is not created. You can probably guess why. If not, we can take a look at the policies. This one is fine. The other one, DB production, blocked the database from being created, and this time it even says it. It says yes.
Cannot be small.
Exactly. That's the real issue there, and we can fix that. I will fix that by changing. There we go. The size of the database. If I ever find where it is. Okay. This is no, wrong file. This is the file. Vim. There we go. DB size. Let's put it to medium. Right now it will fulfill the requirements of the policies, because the requirement said it can be small, medium, or big anywhere, but in production it cannot be small. So I'm saving it. I'm using YTT to generate YAML. Trust me, this YAML now most likely, if I didn't make a mistake, contains the value medium. I will push this to Git, and I will, what will I do? I will now go back to Argo CD. Here we go. And we're going to stop this nonsense. Just not to wait for too long. And we're going to sync it again to refresh it. Okay. Now the database probably, you see how things are changing, happening. And let me see what else. And now if I get SQL claims, you can see that it was created, right, 13 seconds ago. Now the policy allowed me to create that resource, whatever that resource is. Now, since I'm running by your choices in AWS, it takes approximately 10 minutes, I guess, to create a database, but there is probably no need to wait for it. You saw policies worked, it prevented me. No, preventing is a wrong word. Policies guided me, I like that way of explaining, to do the right thing. I already complained that I don't like the term, that's why I don't like the term, the name Cube Warden. We're not preventing people, we're guiding them. And I was guided by myself in this case.
What I enjoy about the fact that that it wasn't right at first is that policies are really powerful, and if they can break your stuff, so they should be used with caution and used wisely. And a lot of these tools even have like a validate kind of mode before, or like an auditing kind of mode, so you can test your policies and make sure before you bring them live you're not going to break your stuff.
I have personally, I don't like validations because I think validations are a way how to ignore things, right? Oh, this is not right, but I can ignore it, right? So I like them failing. But that being said, if you're just starting, right, you already have things and they're not necessarily how you want it. You probably want turn on audit mode or validation mode initially until you get to the point that you're confident, but then just block it.
Awesome. Well, I also want to say briefly that I appreciate everyone weighing in about Twitter versus Slack. We got Twitter is more traction, but then we get Twitter. What's that? And then we have Prithvi like bringing in a whole third choice. I don't. Thank you, but I can't complicate it further. But overall, it seems like we're getting a let's not use Twitter for anything kind of vibe.
I agree with any choice as long as it's Whitney's job to do it.
Oh, gosh. All right. So with all of that, we're going to bring Thomas on. Thomas is going to get 5 minutes only to talk about Falco, and we're going to time Thomas and cut him off. Wait, give him a ready, set, go. Let's get the screen shared.
Yeah.
Hello again, Thomas. Here, this screen is shared, and Victor will start when you start talking. There you go.
I'm ready, I hope. So I will be quick. It's not easy to have a speech for only 5 minutes, but basically I will introduce to you what Falco is, how it works, and what we can do with. Basically, as Victor explained before, Falco is based on the collection of the syscalls at the kernel level. We use eBPF to collect the syscalls. Then Falco will enrich them with human ingestible data, like, for example, the container ID, the container name, the pod namespace. And with the syscalls and all the enrichment, we will apply rules over them to detect suspicious behaviors, possible threats. You can imagine Falco like a security camera over your host, containers, and pods, and more. We'll explain about that later. Then Falco will trigger some alerts, and you can forward these alerts to whatever you want. We have a lot of integrations. The basic ones are in yellow boxes right now on that diagram, but we can do more. This is an example of a rule we provide. It's really easy to understand, easy to read, even if you are not familiar with runtime security, with what syscalls are, and so. You can create the output you want with the element you want to have at the end, for example, the username or else, and you have tags and priority and so. Of course, in that journey, we don't want you to feel alone, so the community and the Falco maintainers provide to you a list of default rule sets to detect the most common patterns we may face with the bad internet. Basically, we know all hackers, all attackers will try to reach the same goal, whatever they face on, whatever the CVE used, whatever the flow they found out, they will try to do privilege and escalation. They will try to start a crypto miner, a ransomware to extract data, and so on. So we have default rules to detect all these events, whatever the solutions that had been chosen by the attacker to have access to. It's nice to have these alerts, but it's also nice to integrate Falco inside your already existing infrastructure. So we provide Falco Psychic. This is when I say that I created something, this is it. And basically, Falco Psychic is in charge to forward the Falco alerts to right now up to 64 different outputs. So you can send them to Elasticsearch for statistics, to Loki or else. You can wake up your SREs with your on-call system. You can also send all these alerts to your function as a service systems, to your serverless infrastructure to react. So right now we have integrations with Lambda, OpenFast, Knative, Google Functions, and so. So we have the detections with Falco, we have the notifications with Psychic, and you can react. And we are not only scoped to syscalls anymore. Falco comes now with a plugin system. Basically, if you have events, you can send these events to Falco, and Falco will apply rules over them. So right now we have plugins to collect the audit logs from Kubernetes, the Kubernetes control plane. We have a plugin to collect the cloud trails, cloud trail logs. Nomad, we are working on that with HashiCorp and others. So you can protect with Falco. You can see everything that happens with at the cloud your cloud account level, inside at your Kubernetes control plane level, and also at the port level. So you have layers of security, and you also have a GitHub webhook. We can ingest the GitHub webhook to secure your GitHub organizations, your CI or else. So the big pictures is there. We have Falco, which collects syscalls. We have plugins for other events, and we also have tools around like Psychics for notifications and Falco CTL for managing everything in a single way. And I'm done.
Victor, you're muted. Wait, Victor was getting really excited to cut you off.
We missed the gong.
I was not. You just stopped at exact time, so you didn't miss anything.
I cheated. I had my own timer on the side.
Thank you so much for that great presentation. And I'm going to hide you away and bring Barun on. Let's get our the banner off. Aha, we're going to switch this to CubeArmor. We're going to bring Barun on. Hello again. Are you ready?
Yes, sir.
Here we go. Oh, wait, before we go, wait. I just want to say that if you have any questions, please do put them into chat, and we'll get to them during the Q&A part after this presentation part. All right, Barun, here we go. You ready?
Go.
All right.
Hey folks, so KubeArmor is a cloud-native runtime security enforcement system that restricts the behaviors such as process execution, file accesses, and networking operations, all we talked about already, of containers and nodes at the system level. It could be your Kubernetes pods, containers, or it could be any virtual machines, bare metal virtual machines as well. KubeArmor is a cloud-native sandbox project, and we have applied for incubation. So I want to primarily talk about, since I said KubeArmor is a cloud-native runtime enforcement system, what's enforcement? What's the different ways of enforcement? So primarily, there are two ways of enforcement. One is async enforcement, where the malicious activity is detected. There are events, there's a detection mechanism, and there's an event handler here or a SecOps person analyzing those activities, and if it deems it as malicious, goes in and initiates a kill or tries to contain it. But by the time this entire life cycle happens, it could be too late. The malicious activity could have done its damage already. And that's where inline enforcement comes into picture. So the malicious activity, as soon as the malicious activity happens, it is denied then and there itself, so preventing any further damage. And KubeArmor utilizes Linux security modules and eBPF to provide that inline enforcement to you, so that the malicious activity can be contained when and as it happens. So let's take a look at a real life example for preventing this. So I will use HashiCorp Vault as an application here. It's an open source secrets management engine, and we are going to try to secure the secrets management as well. So Vault itself stores all its data in certain mount points called Vault data, Vault config. And what if some certain attacker gains access to this? And so you may say that the secrets stored inside volume mount points are already encrypted. Why does it matter if someone tries to access it? But what if the attacker goes ahead and adds an encryption layer on top of that? You are now not able to access secrets yourself, and you are pushed out of your organization. Now you will need to pay ransom to gain access back to it. That's where KubeArmor shines. You can create a zero trust policy such that anything outside of Vault is not able to access these mouthphones. Let's see it in action. I have a Vault policy here saying that block access to anything inside the Vault directory, but allow this access to this particular binary, which is bin Vault. The bin Vault process can access the Vault binary. And I'll go ahead and apply this policy. If I now execute into the pod and try to do anything here, I will get permission denied. I cannot even list the files inside it, and I will receive a security event for the same. I will just simulate it again, and I get the security event that, okay, Vault, something happened inside Vault. These were some system-related information. I had a busybox binary executing, and it was finally permission denied. Cool, my attack was contained. But if I go ahead and try to see, I can still access. Okay, I guess the port forward stop. I'll just start it again. I can still access the Vault UI, and everything about the Vault is still working as expected. So that's how KubeArmor is securing you. And if I go ahead and delete this, I can now access everything. But this is, you may say that I need to understand my application to generate these policies. But you don't need to do that. We can have policy recommendation based on certain compliance frameworks, such that you don't need to think about. And you got the
You cannot see me because my camera died. I'll figure it out. Today is not the day, but you're over. You're out.
I'm all done. I gave you the opportunity. So.
He's you can't hear him, but you can't see him, but you can hear him, and that's the important bit right now. I think getting gonged by Victor is a rite of passage. I think it's a badge of honor. I think it's fantastic.
And take it as a blessing.
Exactly. Thank you so much. I'm going to bring Thomas onto the stage here. Hello, both of you. We don't have any questions in the chat right now, but I have some questions, so I'm going to dig in. One was for Thomas, and that is, you talked about the plugins. So I'm relatively new. I'm trying to understand everything. And so you talked about Falco plugins as additional sources in addition to like system call, like kernel level stuff. And one of them you mentioned, for example, is Kubernetes. So I'm trying to understand, like, what is the difference between using a tool like Caverno to implement a Kubernetes level policy versus using Falco and this Kubernetes plugin to implement a Kubernetes API level policy?
Basically, the two tools are really complementary. Basically, with Caverno or else, we'll try to block any suspicious access to your control plane, any actions that should not happen. And if your policy is not good enough, or if you missed an angle, you will have Falco on the other side to detect, oh, you missed that, and we detected something that was not supposed to happened. So even with CubeArmor, all these tools are not really competitors. They are working all together to create a runtime security from A to Z. You protect the requests received by the client, but you also protect your applications from itself. When you run a pod with an image created by someone else, you are not 100% sure it's really clean. You should not build your own images. But if you do so, you have tools to protect their behaviors. You have CubeArmor to scope what they are supposed to do, and you have Falco to detect if they are doing. For example, you can detect if a Node.js application is trying to reach an outside server, for example.
Excellent. That's helpful. Can you maybe, how about Barun? Can you give an example of when you might want to use Falco and CubeArmor together? And this is actually, I'm going to go ahead and shout Adrian out too, because they're asking too, can you integrate the two solutions to react to threats or treats?
So Falco has evolved as a ecosystem, right? It has a lot of elements. The Falco engine itself, it has Falco Sidekick and a lot more things. Thomas talked about Falco Sidekick, where it has a lot of integration models that it can send information to many SIM tools or logging engines, Elastic, and all that. So we ourselves are planning to integrate CubeArmor events such that we can utilize Falco Sidekick, such that everything can be sent, because Falco Sidekick already integrates everything, right? We just push it in that format, and then we have out of the box integrations to all that. So that's where I guess it shines.
That's better than an example. It's a full-on integration. That's cool. We have a question for Thomas. Why does Falco have to run on the kernel level?
To collect the syscalls, basically, with the BPF. So Falco itself is not running at the kernel level. To be really specific, Falco itself is running in zero space, but the driver is based on eBPF. Will collect the syscalls in the kernel level, and thanks to a ring buffer, the events will be exported from the kernel space to the user space. So Falco itself is not in the kernel level, to be really specific.
Okay, so Falco runs in user space and has a driver at the kernel level.
Yeah, exactly.
And then another Falco question. Does Falco have any plans to add a feature for reacting to threats like CubeArmor has?
Directly inside Falco, we don't want to integrate reactions or things like blocking syscalls or else, because we have big focus on the performances. And we try to have something with performance, but we are working on other systems. For example, on my side, for example, I created Sidekick to forward the events, and I'm working with some people in the community to create a tailor-made response engine for Falco. Basically, it's an engine which understands out of the box the Falco syntax, the Falco of the rules, and is able to react based on some specific patterns. It's an alpha stage, but.
So if I understand correctly, that's Falco Talon is what you're describing right now. Is that correct?
Yeah, exactly.
Okay. And so Talon is a little, correct me if I'm wrong, but I think Talon's a little different in that it still happens after the attack. So if so it kills the container, but it kills it after the attack happens, when CubeArmor still is able to stop it before it even happens. Is that correct?
It's a reaction. Exactly.
Cool. And then I have a question. This is going to be for both of you, but I'll start with Barun. So both of you talked about the fact that you have policies already available for people to use. And can you tell me what's an example of a policy, a ready-made policy, and how you even decide what's important enough that people, or I guess ubiquitous enough that people need to use it?
So the policy recommendation part, which I was going to show, but now I have a chance to talk about it. So these recommendations come from, there are already a lot of compliance frameworks out there, like MITRE, CIS, NIST. A lot of tools use that to generate whether your clusters are compliant or not. And our policies use that as a source as well. They define certain things like you should not be executing package managers in your containers at runtime. So any packages which already exist, should already exist beforehand in your containers. These should not be executed at runtime. So now you have a policy generated for you that, okay, all the package managers like APK, apt, yum, we
Okay.
have a set of those, and you have a policy for that. And similarly, a lot of other use cases like file integrity monitoring, protecting your certificates, and these are your sources of policy recommendation, and they are generic enough for all containers generally. So that's how we can recommend policies for containers. Yeah. And
Okay.
these are for KubeArmor. These come from, we maintain a repo called policy templates. It's a community repo, and anyone is free to contribute. People contribute there. We recently started supporting STIGs so like a lot of compliance frameworks are being added there because it's a community repo. So that's how it's growing, and we have utilities around so that they are generated for your specific apps.
That's awesome. And what about, can you say something about the Falco community, the policies that are already ready to use?
So for Falco, basically my answer will be in two parts. The first one is maybe the attendees are familiar with the meter framework. It's a framework which describes basically techniques and tactics used by hackers to do bad stuff. So we are trying to cover this matrix. And to do so, us, the Falco maintainers, we are creating rules, and we are also receiving rules from the community. And to be sure, these rules are legit, performant, and they are not creating false positives. We are following the CNCF for what the CNCF does with the projects. So for the rules, we have these exact same levels: sandbox, incubations, and stable. Not graduated, but stable for Falco. So when someone from the community proposes a rule, the rules will be from start in the sandbox file. So people will be able to test it, to improve it, and after a while, it will become at the incubation level and so on. So it can take a little bit of time between the first PR and the final rule, even a year or two. But at the end, all stable rules are battle tested, and we are sure they will not create noise, because the noise fatigue is noise tightness is a nightmare for
Just
the
like
security
we
engineers.
saw in Victor's demo, even though that's a different kind of policy, it's still the same idea.
Exactly.
Yeah. So these are battle tested, and you can trust that a lot of time and efforts has been put into it to make sure it's not going to break your stuff. And one thing that so when you talk about, okay, these tools could work well together, and also Falco could work really well with Caverno or with a Cube API kind of level. It's a little, as someone who's new to this whole scene, it's a little overwhelming to me to know when you stop, like how far do I have to go to secure every teeny little thing? Do you have any advice for someone like me who's overwhelmed? Barun, let's go with you first.
The only solution here would be to introduce yet another tool which could orchestrate everything for you.
Exactly. That's how we fix it. Are you how much are you kidding? Is there really another tool?
Spoiler alert, I'm not kidding. Actually, we are building something like that.
Hey, welcome back. We missed you.
Yeah, I'm trying to figure out. Had to find a random webcam that might or might not work. We'll see. Okay.
I love it. I feel like I'm getting the backstage pass right now. There's a photograph of something behind you. Yeah. I got to see the lights change from normal
that's
to
something.
Victor. Oh,
That's something is
on the other side of you. That smoky lady I've seen a lot of times in your older videos. Yeah. Anyway, we're talking about Victor. Sorry. Do you have any questions, Victor, about runtime policy to ask about these two tools?
No,
just
no,
a
I
thing
was
to
too
complete.
concerned with finding the cables and chargers and stuff. So ignore me.
Well, that's all right because our time is up anyway, really. So what we're gonna do next is have you each give a closing statement. So just a quick synopsis of your tool and why people should vote for your tool. And just a reminder to the guests and to everyone, this is not a competition at all. It's just, even though we're gonna have a vote, the one that gets chosen is just the one we're gonna implement in our ongoing demo. It in no way means that it's a superior tool. So it's just what people are curious about. So anyway, Thomas, give us a couple sentences, 30 seconds on why people should vote for Falco.
Well, Falco is close to be a graduated project as a CNCF, so it's really well beta tested. A lot of big companies are already using it to protect their infrastructures. We rely on modern technologies like eBPF to be sure we collect the right thing at the right moment. And with so many rules, we are able to detect so many bad patterns that may happen. It should be a no-brainer, and everyone should install it in their Kubernetes clusters.
Excellent. Thank you so much, Thomas. And thanks for being a guest. Thanks for sharing your time and expertise. Bye. Barun, tell us why to vote for CubeArmor.
Okay, CubeArmor helps you prevent attacks before it happens. And we are using eBPF and Linux security modules. Both are eBPF is being widely used, as Falco talked about, and Linux security modules has existed in the kernel more than 2 decades. So it's a trusted source of preventing having security. And that's how CubeArmor helps you prevent attacks. And so use CubeArmor to armor up your clusters. That's all.
Perfect. Thank you so much, Varun. Appreciate you. Have a great day. Bye. All right. So we have in our You Choose channel on the CNCF Slack workspace right now. I just put a poll up. And so we're here and ready to vote. Do you have a link to the CNCF demo handy?
Yes, yes. To the repo or to the voting?
To the voting. I think that's a link to the voting.
Yeah, that's
hopefully.
the one. That's the one.
It's slightly easier that way, but really just go to the CNCF Slack workspace and put your vote in there. Yes. And is there what else we need to say? Next week is so this voting lasts for 3 days. And then next week we're covering tools for secrets management.
Yes. We are covering, and they're kind of all very different, right? It's similar to today's show, I feel, but with more tools. That none of them is a direct competitor of the other. They're all solving problems in very different ways.
Which, well, really, I enjoy all of it, but I love hearing like what are you doing that makes one tool a better solution than another tool. That's always fascinating to me. Cool. Anything else to say?
No, I think that's it.
All.
That's a wrap.
Awesome. Thank you so much, everyone. We'll see you next week. Bye.
Cheers.